All right, so we are going to go through the process of building this spring in Onshape. So the first thing we need to do is open a new document. Our work length unit is set to inches already, so we don't have to do anything there. And we're going to begin a sketch on the right plane. So I'm going to create a new document. I'm going to call it spring, my last name, period 5. Spell my last name right. And I am going to begin a sketch on the right plane. All right, next I'm going to sketch the circle, and I'm going to make a horizontal construction line and a vertical construction line, each coincident to the origin. Then the two lines are each going to be tangent to the circle. The end point of the horizontal line is vertical to the center of the circle. So these 2 points here are vertical. These 2 points here are horizontal. Okay, so, and I noticed that the diameter here is 0.375. So when you start making your circle, you want to kind of pay attention to how big you're making it. 0.375. So I'm going to get my circle tool. 0.375 is pretty small, so I might want to zoom in a little bit. And I'm going to make this 0.37, that's pretty close, and then type in 0.375. So now I got my circle with the diameter that it's supposed to have. Now I need to do those vertical and horizontal construction lines. One. There's one. Then I want to make, I'll do these vertical constraints right here between these 2 points. And then the end point here and that center point need to be horizontal. And then we want each of these lines to be tangent to the circle as well. So now this sketch is fully dimensioned. So we go ahead and accept this sketch. All right, now we're going to create a helix from this circle. So we're going to select the helix feature. We're going to choose turns and pitch in the pull down. We're going to select the edge of the circle for our circular edge. We're going to pick counterclockwise for the turn direction. Input 7.25 revolutions. Helical pitch will be 0.085, and 0 degrees is our starting position. Then down here it says, notice the helix starts at 0 degrees, which is horizontal to the center point of the circle, blah, 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 blah. Okay, yeah, it says that. Okay, so we're going to do this helix. So the helix tool, where are you at, helix tool? Oh, yeah, it's composite curve is under the same one. But it should just start off as the helix right here. So we click on helix. It said to pick turns and pitch. Our circular edge, just click on the circle, and I'll kind of tilt the view so we can see the helix start. We want to go counterclockwise. Revolutions was 7.25. helical pitch is 0.085. And I think that's all that stuff right there. Okay, so we'll accept that feature. What's next? We're gonna begin a new sketch on the front plane. And it says to notice by starting the helix at 0 degrees, the end point of the helix is on the front plane. So if we show the front plane real quick, it's really big, but you can see the end point is actually on that front plane. So depending on where you want your point on your helix, you might have to type in a different angle, but this one worked out where it's on the plane we want. Okay, so we're gonna make a sketch on the front plane. Okay, now this one's gonna be a little bit tricky to do because they start off with a little tiny curve right here and then a vertical line. And then they do a horizontal line, and then they come back and put a fillet to make this little curve. But this tiny curve right here makes it kind of difficult to work with. And I'll show you what I mean. So we need to start off with a tiny little 3-point curve right here. And then you got to watch out that you don't get accidental geometry constraints like this. This would be a vertical constraint we don't want. What else could it give us? It might give us a point vertical to the origin. We don't want that either. But it's just a little curve. And then we need a vertical line and then a horizontal line. So there's a vertical line and my horizontal line. And then we are going to get this, okay, we can do, I'd say let's do some of the dimensions first, and then we'll get, because all these curves have to be tangent to each other, or these two have to be tangent to each other, and this to tangent to that. So I want to put some of these dimensions on there right now. So I'll start with the 1/2-inch dimensions. This is 0.5. And then the other dimension is from the top line down to like the end point of the helix. So from here down to this point right there. It's also 0.5. And now I'll see if I can put those tangent constraints between the vertical line and the little curve. And then between this curve and the helix. So then this thing got really small. So I'm going to try to drag that to where I can see it and then put the radius dimension on it. The radius was 0.625 for that curve. .625. Now that part gets all defined. And then we just need to put the sketch fillet with a 0.08-inch radius. So here is our sketch fillet. Click on this corner. 0.08 is the radius we want. So now this sketch is fully defined. And then all it is it's this little bendy part that continues out of the helix. So then we can accept that sketch. Next, we're gonna do a sketch on the top plane. And so if you notice, the top plane is the plane that has the other endpoint on it. So I can get a good view of that. That other endpoint is on the top plane. So we're making a sketch on the top plane. And it's basically the same as the other sketch was, but upside down. That same little curve, then a vertical line, then a horizontal line, and then the same little sketch fillet. Okay, but we're starting from this endpoint. So and then I'm going to go ahead and just type the radius on there right now. It was 0.625. And see how it makes it all jump all big and crazy. I'm just going to wait on that. Try to fix that. I'm going to make my horizontal line and my my vertical and my horizontal line. Okay. I don't know. Did this get to be, what's it perpendicular to? I need this to be vertical. There we go. So now that I got, there's a tangent constraint here. Okay, so it's already tangent to the vertical line. So now if I can make this tangent to the helix, then I just need to put the dimensions on our straight lines. And then from this end point of the helix to there, 0.5. And then the sketch fillet on the corner down here. And then we can go ahead and accept that sketch. Okay, so now we're going to make a plane that touches this endpoint here and is parallel to the top plane. So hit the plane button. We're going to do plane and point. Plane and point. So I'm going to select this point and then the top plane, and it will give me a plane that's parallel to the top plane, but that goes through that point. So now we got this top plane that goes through that point. And we're going to make this sketch on it. So we've got a vertical line here, a horizontal line there, and then we have a couple of 3-point arcs here. There's an equal constraint between them. There's tangent constraints between everything. And so let's do that. So I'm going to select that plane, make a sketch. I'm going to hide this other stuff so that it's easier to see. I'm going to hide that. And which one here? And that one. Okay, so I'm going to make an arc here, vertical line, arc, horizontal line. And I'm careful not to accidentally line it up with anything, right? So, boom. Then when you're moving it, you can go ahead and put it where it does a tangent constraint to that line, because we need that anyway. Then the radius was 0.08. And we need a vertical line. And then another arc. And then a horizontal line. Now I'm going to make sure I get tangent constraints. So I've got this one says I have a tangent constraint between the vertical line and the lower arc, but I need it between the vertical line and the upper arc as well. This bottom arc is tangent to the vertical line, but we also need it to be tangent to the horizontal line. And now we just need some dimensions, I think. 0.5 there. Oh, there's an equal constraint between the two arcs. So I'm just going to select both arcs and then do the equal constraint. And then the only thing that's left is just to say how long this line is. And so that's dimensioned from there to the vertical line, 0.375. From the endpoint to the vertical line, 0.375. Now this sketch is all defined, so we can accept it. And then I'll show the other stuff that I had hidden. I'm going to hide the plane one that I made also. Okay, so now we are going to make another plane from the other endpoint. So we're going to do plane point. We're going to pick this endpoint and the front plane. And if you can also pre-select them. If you just select that endpoint and then front plane, and then you push the plane button, it'll automatically pick plane point for you. Okay, so now we are going to make a sketch on that plane, hide the other stuff, and zoom in a little bit, and it's just one little arc and then a vertical line. So make a sketch. I'm going to hide the helix. And I'm only going to keep this lower, like horizontal stuff here. So I'm going to hide this stuff here, which is, I guess these others. Nope, I want to keep you there. So now from here, I'm going to make my little 3-point arc and then a vertical line, put these measurements on there. 3-point arc. Make sure you don't accidentally get it vertical to the origin, but you can get it tangent to that if you want. And that one had a radius of 0.08. And now I'm going to make a vertical line. And then I'm going to put a tangent constraint between the vertical line and the arc. And I need to say that the height here is 0.375. But I need my dimension tool in order to do that. The sketch is defined, so we can accept it. And then I'll go back and show all the stuff that I was hiding. Okay, so now we're going to use the composite curve function to create one curve out of all the different things we put together here. So the composite curve button is under the helix button, this drop-down menu. Select composite curve. And then it gives a little hint over here, right click and choose create selection to make it a little bit easier to select all those things. And then if they says there's a loop option under edges, so you only have to click one thing. So I'm going to right click, create selection, loop chain connected. So then I'm just going to click on one of these. And it should take everything. Why isn't it doing all of it? Tangent connected. Yeah, see, this doesn't work very good. I think it's easier to go like this, clean that out. For the edges, just go like that and just drag around all of them. So then what happens is when I accept this, it's going to tell me I have two curves now. Curve 1 is just the helix that we made. Curve 2 is the curve that includes all of that stuff. So I'm gonna hide curve 1, which is just the helix, so that I don't like accidentally just select that. Now we're gonna make another plane to do our sweep profile. So we're gonna make a circle here that's gonna get swept along this whole curve. So we're going to create a new plane. We're going to do point and normal. So we're going to select this top end point and this line. And so it'll make us a plane that is through this point, but perpendicular to that line. So I'm going to select this end point and this line. And then I'm going to click the plane button. And notice that it automatically picks point normal. So now I have a plane that goes through that end point. And next we're going to make a sketch on that plane with this circle, radius 0.08. And accept that. And then we're going to do the sweep now. So sweep, solid, new, faces to sweep. This is the circle we want to sweep around. The sweep path, if you click on this, it's going to accept all of curve 2, right? I think, or if you just click on this, it'll just go right there. But if you say, you can just come down here and click on curve 2 and it'll take the whole thing. Alrighty, so the next thing, we're just going to name the part spring. Now we have a part in our part menu. And then, as you know, you can select it and hit mass properties, find the volume, 0.059. and then check it like that. Or sir, they do surface area on this one, 2.976. Alrighty, folks. That's how you make your spring. Yay! And you can make it cute by making, if you take off the edges, be shaded without edges. There you go. I'll stop the recording now.